Hi, today we are starting a new unit on chemistry, and we're going to start talking about atoms and molecules and how they relate to our project on plastics. So we're starting with Learning Target 1 and 2. Learning Target 1 talks about how everything in the universe is made out of atoms and elements, and Learning Target 2, LT2, talks about how you are able to draw a simple diagram of atoms with protons, neutrons, and electrons, and you can relate it to how there's different atoms that make plastic. So let's get started. First, let's define what chemistry is. So chemistry is a new word. Basically, chemistry is the study of matter. Okay, and what is matter? Matter is everything in the universe. Um, it's basically made up of extremely tiny particles called atoms and molecules. And these atoms and molecules can exist as solids, liquids, or gas. And basically, some examples of matter are people, trees, computers, air, water, everything in the universe is made out of these tiny particles. And chemistry is the study of these tiny particles and how they interact with each other. And a lot of times we're able to understand what's happening to the world around us because of chemistry. And it's not something you can you can't really see the particles, but you can see the results of the particles, especially when there's things like chemical reactions happening. You can see changes happening. So let's tie this idea of chemistry with plastics. So, like I said, everything's made out of matter, including plastic. And plastic is made out of certain patterns of atoms. And if the more we understand how plastic is made with these and how the atoms in plastics are arranged, the better we can engineer new plastics for our project. And so I really want us to learn about the atoms and the ways that plastic is made so that when you start making your bioplastic, you might have a better idea of how maybe some of the interactions of the atoms are working in your recipes. Now let's talk about what an atom is. So an atom is the smallest particle of matter. So you know that everything in the universe is made out of matter, and the smallest bit of matter is an atom. There's many kinds of atoms in the universe. These are some of the most common. We have hydrogen, carbon, oxygen, nitrogen, calcium, and phosphorus. We are made out of different kinds of atoms. And if you recall from Unit 1 in our Ecosystems unit, we had studied the cycling of matter, or the different cycles that kind of recycle these atoms throughout the ecosystem, such as the carbon cycle, or the water cycle, or the nitrogen cycle, right? And so these atoms are constantly being used for our bodies, but they're also being constantly recycled in ecosystems. And they're really important for our existence. Okay, now let's dive deep into the structure of an atom. So, as you know, atoms are the smallest part of the universe, right? Or of any matter. But if you are able to see inside of an atom, they're actually made up of much smaller particles. So, if you look at this diagram, it actually shows you the basic components of an atom. In the center, we have what we call the nucleus. And then that nucleus is made out of two different types of particles. The first type of particle is a proton, which is a positively charged particle in the nucleus. And then the second type of particle is called a neutron. It's basically neutral. That means that there's no charge, but it's also a particle in the middle. Okay, and so we have positively protons and neutral neutrons in the center. Now, if you look on the outside, we have these rings, and the reason why they look like rings is because these yellow dots, these are electrons, they actually are kind of spinning around the nucleus, and the path they take is on this ring, and that's why we draw these rings. But these electrons are negatively charged, and they're spinning around the nucleus. Now let's talk about the periodic table of elements. So this is a big table that shows all the different kinds of atoms that have been discovered so far in the universe. And you could see there are over 100 atoms, and they all have very unique names and properties. So now let's talk about what an element is, because we call this a periodic table of elements, right? So an element is a substance that is made up of only one type of atom, and we cannot break the element down into smaller parts. And so here's a diagram that kind of shows you the difference between elements and compounds. And so we can see here helium is a type of atom. This is a helium. This is element. Oxygen molecules. It's only made up of oxygen. And so again, elements are basically a substance that's only made up of a single atom and they cannot be broken down. On the contrast, we have a compound on this side, and you can see compounds are made up of more than one type of atom. We have two hydrogen atoms connected to one oxygen atom, and so because this is made up of more than one type of atom, we do not consider this an element. Now let's talk about the differences among the atoms of different elements. So in the periodic table, if you zoom into any portion of the periodic table, you'll notice that there's different symbols and names and numbers, and they all have a meaning. So we're going to learn about that, but just know that each box represents a different type of atom, and each box has a specific information about that type of atom. And we call this information the atomic number, atomic mass, and the symbol. So now let's take a look at what each of these components mean. So right here is a zoomed in picture of the carbon portion of the periodic table. The first thing you might notice is a big letter. We call this the chemical symbol. It's usually one or two letters, and it's an abbreviation of the actual element name. So C for carbon. Underneath the symbol, you'll find the actual name. Usually above the symbol or sometimes in the corner, you'll find a single number with no decimals. This is called the atomic number. Basically what the atomic number is it's the number of protons and electrons in the atom. And so you can see here carbon has 6 protons. That means that there's 6 positively charged particles in the center and 6 electrons whizzing around in the electron cloud there. Down below, you'll find a number that has multiple decimal points. Basically what that is, it's the atomic mass, and it's actually the average weight of the atom. And they calculate the weight based on the number of protons and neutrons in the nucleus. Because they know the weight of each proton and neutron, they can approximate the weight of the entire atom. Electrons usually are very light and they don't weigh much, so usually the mass is only about the protons and neutrons. There's one more number called the mass number. Sometimes they include it in the periodic table, sometimes they don't, but basically the mass number is the sum of the numbers of protons and neutrons. And the reason why mass number is separate is because sometimes the mass number can change based on the number of neutrons, and an atom can sometimes have more neutrons or fewer neutrons. We call these isotopes. I'm not going to get into this too much just because I just want you guys to understand the basics, but just know that these atoms can exist in different ways based on the number of neutrons. Finally, let's make the connection between the periodic table, atoms, and plastic. And so, again, we're working with a project on plastic. So you might be wondering, well, what kinds of atoms make plastic, right? So plastic, as you guys recall, is made out of oil or petroleum, and those fossilized remains are mainly what we call hydrocarbons. So basically what that means, it's long chains of carbon and hydrogen atoms stuck together. So you can see here, these are long hydrocarbon chains. And so carbon and hydrogen are two of the main atoms that make up plastic. And we might want to keep that in mind when we are making bioplastic, because basically what you want to think about is, do the atoms in bioplastic look similar to the atoms, the way that they're arranged in normal plastic, right? But let's go ahead and look at these two atoms in more detail. So on your paper, I would like for you to draw the carbon atom. We have 6 protons in the center, and 6 neutrons in the center, right? And then we also have 6 electrons around the nucleus. In the first ring, put 2, and in the second ring, put 4. I'm going to explain why there's 2 in the first and 4 in the next another day, not today, but just for now, go ahead and record that there's 2 in the first shell and 4 in the second shell. If you look at the periodic table of elements box, and you can match the number of protons with the atomic number. So 6 protons, so there's 6 in the atomic number. And so you can make that connection there. On the right side, I would like for you to draw the hydrogen atom. In the center, you have 1 proton and 1 electron. Oh, this is a typo. And you should be drawing 1 electron on the outer shell. And if you look at the atomic number, you can see that there is a matching 1 here for the electron and the proton number. And that's it. You have the basics of atoms, elements, and the periodic table. And now you can continue on and to the blend space.